All right, so this is a problem that's not in your textbook, but it's just like the ones we've been doing. So we'll do the problem y prime minus 5y equals again a discontinuous, a piecewise defined discontinuous forcing function. We've got t when t is between 0 and 1, and we have t cubed minus 1 when t is greater than or equal to 1. The initial condition is y of 0 equals 1. Again, we want to do this using Laplace transforms, but we need to be able to rewrite that right-hand side in terms of unit step functions. So y prime minus 5y equals, the function starts at t, don't need to worry about a unit step function here because we started at 0, plus unit step function of t minus 1, because we have the definition changing at t minus 1. Now remember, we can do this easily. We want to put in where we start, or sorry, where we want to end up minus where we started. So that makes life a little bit easier to be able to do that. All right, so we are ready to take the Laplace transform both sides, but notice that we have the unit step function of t minus 1 here. Remember that what this part is, that it has to be a function of t minus 1. So in particular, we've got to do a little work right here. So let's just do that off to the side. Let me zoom out a little bit here to do this off to the side. I want that to be t minus 1 cubed because I need a function of t minus 1. Okay? So remember, this is going to be t cubed minus 3t squared plus 3t minus 1. So if I want to replace this with t minus 1 cubed, remember when I multiply that out, I got a minus 3t, a plus 3t, and minus 3t squared and a plus 3t and a minus 1. I'm going to have to add those back to make sure we keep everything equal. Plus 3t squared minus 3t plus 1. And then I've got a minus 1 and a minus t here. So, again, this is all side work. Because I still have to get this back up here times this unit step function. I'm going to go ahead and just write it here. All right, I have this as a function of t minus 1. Those two pieces cancel, and of course I can get those like terms. But now I need to work on this t squared, because I also need that as a function of t minus 1. So I have to write the t, again, off to the side here. T minus 1 squared is t squared minus 2t plus 1. So if we go to the next line here, we would have t minus 1 cubed plus 3 times t minus 1 squared. To keep everything equal, I've got to add back the 2t and subtract, add back the 2t and subtract the 1. And I still have the minus 4t here on the end. The 4t, of course, coming from the negative 3t and the minus t. And notice I've been working on this a step at a time, right? I worked with the highest power of t that I had to get it as a t minus 1. And again, the reason we're doing this is because the argument of the function has to be the same as the argument in the unit step function. Okay? We're going to end up treating this like it's the variable when we take the Laplace transform. All right, over here, we've got a negative 2t, right? When we combine these two terms, what we really want to do is make that a t minus 1. That's negative 2t plus 2. So this should be the last step that we have to do. So you again, just writing all the stuff that we've already done before. If I have a plus 2 times, or excuse me, it was a minus 2 times t minus 1. That's negative 2t plus 2. We've got to subtract off the 2, because we changed the 2t to the 2, or 2 times t minus 1, and we still have a minus 1 here. So really, this, of course, is just minus 3. Now we're ready to take the Laplace transform. Here we get s f of s minus f of 0. And we get minus 5 f of s. Laplace transform the right-hand side for t is just, of course, 1 over s. Now here's where we do the Laplace transform for the unit step function times a function. Again, reason why we did all of this extra work on the right-hand side was to get a function of not just a t, but a function of t minus 1. And we're going to treat each of those like it's the variable when we do the Laplace transform. So for the unit step function, we'll have e to the minus s, because our a, remember t minus a is e to the minus sa, we'll have it in front. And then we treat this like it's a Laplace transform of t cubed, Laplace transform of t minus 1, t squared, sorry, t and just the constant. So we'll get 6 over s to the 4th, and then plus 3 times 2, so we get 6 over s cubed, minus 2 over s squared, and then minus 3 over s. Again, remember, the reason these are just s's, of course, is because these, again, are just we're treating each of those t minus 1s like it's the variable. All right. We know that f of 0 is 1, so I need to add it to the other side. We'll factor off the coefficients on the f of s, add the 1 over, and just rewrite the end of this thing. We're not too worried about doing any simplifying here because we're just going to let GeoGebra do the heavy lifting on the inverse transform. All right, so then f of s will equal, I'm just going to write right-hand side, just so I don't have to rewrite it all again, over s minus 5. Let me rewrite this over here so you can actually see the 5. All right. So we need to type in the right-hand side all over s minus 5 over in GeoGebra. So let's go do that. Inverse Laplace. It was 1 plus 1 over s plus e to the negative s times 6 over s to the 4th. I'm going to go back and just check my signs. 6 over s cubed. Stop. Back up here again. 6 over s cubed. Like it said, minus 2 over s squared. And just to double check, I think it was minus 3 over s, but we'll double check. Yes, okay. So, here, oh, I know what I did. Here we go. Oh, that's all right. We had the plus 1 over there. Oh, I forgot to divide by the s minus 5. Let's go back up here again. Sorry about that. So let's put a set of parentheses here. Actually, it did that for me, it looks like. And then we want to divide that by s minus 5. That was why it looked weird. There we go. So there's our solution. It's not exactly pretty, but it's solution. Let's see if we can copy this. Maybe we can copy. Maybe. I edit. Copy. I just don't have to remember what it was. Let's see if it'll work. Paste. Nope. Back over here again. Really don't want to have to rewrite all this stuff again. Oops. Nope, I think that's not what I wanted it to do. Because it just added it all together. So let's see if I can get rid of that. Delete. Delete row 6. That's what we wanted to do. Let's see if we can just replace number 5. I don't know why it said that was invalid. I'm sure why it's having so much trouble. There we go. Well, except it didn't copy exactly what I wanted it to copy. This is the solution, but at least I can write it from here. So the solution would be f of t is equal to negative 1/5 plus 6/5 e to the 5t. And then plus, that's negative 389 over 625 e to the 5 times t minus 1 minus 125 t minus 1 cubed minus 450 t minus 1 squared plus a 70 times t minus 1 and then plus a 389 over, nope. Looks like all of this was over. That's interesting. Looks like I could do this. It looks like we have a 389 over 625 for the whole thing. Oops, not that way though. This whole thing divided by 625. And then unit step function of t minus 1. Again, we're trying to let GeoGebra do the heavy lifting for us, which is why we just went ahead and did this on GeoGebra. On your exam, there won't be one that necessarily this complicated to have to write all this stuff down again. So that was the biggest issue. But again, remember that all we're doing is using the unit step function, or excuse me, using the GeoGebra to do the inverse Laplace transform for us. One of the reasons why this one is so complicated is because of the fact that we've got a complicated thing that we're trying to do the inverse Laplace transform for.